All right. Now we're back in New York to show the full stack New York immersive projects. This is going to be an amazing set of 13 projects. Here I am with Corey Greenwald.
Hello.
Corey is the instructor, is one of the two or three instructors for
Three.
the one of the two instructors for the full stack New York immersive program. And this is really, where it all started. Full stack New York immersive. We have some amazing set of students, amazing set of projects, and these really excited to see what these students have come up with. So, Corey, why don't you kick us off and
Yeah, thanks,
get
David.
started?
Yeah, this is an awesome group of students. I think they're going to hopefully give Chicago a run for their money this year. That's what we're hoping. So we're going to start it off really nice and strong out the gate. We have one team that was really focused early on like solving this problem with getting like genetic algorithm testing into the hands of scientists in a much more easy to use interface. So they focused on dealing with like a large amount of data and having to actually distribute this data, which is a task that scientists often can't deal with themselves. They go to different techs and engineers to actually take care of this for them. And let's go ahead and go over to them and kind of take a look at how they put this thing together.
Hey folks, I'm John. This is Kenny, Daniel, and Abel. Thanks for tuning in. Today we're going to show you our machine learning application called FortySix. First, a simple way to think about a machine learning algorithm is one whose quality of outputs improves given an increased number of inputs. The problem is, they're tough to create and computationally expensive to run. Today, if you wanted to create a custom machine learning algorithm, you'd probably have to write it yourself or hire a developer. And when it comes to running the algorithm, you'd most likely use pay-as-you-go infrastructure. That's why we created FortySix. It's a platform that lets users easily customize and run genetic algorithms. Genetic algorithms are just a specific machine learning technique. It simulates evolution in order to solve problems. Additionally, we take the computational load of one of these simulations and we distribute it across multiple web browser clients. Here's Kenny with more on how we did it.
This interface allows users to customize the fitness function and other common parameters of a genetic algorithm. This means that users can create a new genetic algorithm without creating a new standalone application. We knew that this view could be a potential security concern because we're allowing users to input code that will be run on other users' browsers. To combat this, we implemented Sandbox.js, which uses a child process to test and isolate code and prevent things such as cross-site scripting and infinite loops. Customizing a machine learning algorithm is great, but it's useless unless you have somewhere to run it. Running your algorithm on one computer could take prohibitively long. To overcome this constraint, we broke the job down into many smaller tasks and then distributed these tasks across different web browser nodes in a network. And here's Daniel to explain how we did that.
On the left, you see what the creator of an algorithm sees when their experiment is running. And on the right, you see what a contributor sees. A contributor can come and go as they please without interrupting the continuity of an experiment. When a contributor connects and signals that they're ready to the server will dispatch a task from a task queue, send it down to the client where it's processed, and then send it back up where it's composed into a new task and put on the end of the task queue. To accomplish this, we use WebSockets via Socket.io. This allowed for bidirectional communication, meaning that web clients could sit and wait for tasks from the server. We also used web workers via Threads.js. That allowed us to segment the tasks down even more on the web client to give us that extra speed boost. What you're seeing here is the statistical output of how an algorithm is doing. Due to high throughput and large amounts of data, it was particularly difficult to compute these statistics in real time without creating a bottleneck. Here's Abel to explain more.
So originally we decided that we might set up a microservice just to deal with these real-time statistics, but ultimately we decided our approach could be refined instead. So we optimized using two main techniques, the first of which was multi-threading via child processes, and that allowed us to take in the new data and sort it in a non-blocking way and gave us a large performance boost. The second was a heuristic. And the heuristic allowed us to recognize certain statistical steady states, which told us when we could stop computing expensive computations, cache important results, retrieve them later. And between these two things, we were able to actually eliminate the bottleneck altogether. So those are the main features of FortySix, our genetic algorithm platform. We're happy to have created something that allows people to run and easily customize these genetic algorithms. Throughout the process, we definitely ran into a lot of new technologies, concepts, and overcame a lot of challenges. It was a ton of fun to work on, and we're very pleased with the result. So if you'd like to learn more, you can check us out in our GitHub or find our Heroku app. Thank you very much.
All right, if you would like that post, like the pinned comment. That was really cool, Corey. I think the distributed problem-solving nature of genetic algorithms, all done in the browser, and then getting those like live real-time updates. That's quite something. Quite something for sure.
I think it's crazy that they didn't just stop at like distributing the task between multiple clients, but then also using web workers to like split that task further on a single client's browser. I think that was just really, really, really intuitive and really kind of maximizing performance, and especially like living in the single-threaded JavaScript world, just maximizing that distribution with asynchronous tasks. So that was really, really, really cool.